Thank you, Adam. Great added pressure. So anyway, if this, great, fantastic. So type classes, they're a fundamental tool to the FT developer. But I think many of us can, basically we feel there is an abstraction smell, the same that we have code smell. So there is an abstraction smell in FP when things don't compose. There's something that's not right. So thank you for coming to this talk. We are going to look into how to encode type classes in a more functional way. We will also see how Scala 3 supports this more functional encoding through macros and reworked implicits. And then we'll look at another twist of auto-derivation by live coding some macros and seeing how things could be done in a still very, very experimental way, so it's nowhere near, not even pre-alpha, it's a demoware, but we'll show some code with real things happening that I think they're quite cool. So type classes simply, support generic programming. They answer the question if we have, for example, a distinct method that we want to implement in a generic way. What's the minimal information that we need for this to be able to be implemented? So with this, we cannot implement it unless we cheat as the standard library using the Java equals and hash code. So doing it in an FP proper way, we need the minimal will be an equal from A to A that we can do basically rule out the duplicates. It's not efficient. We will probably also need a hash code, but this is the minimal that we need. So that's the type class helping us. Just some syntax in Scala 3. Things have changed. Usage, just come with me if you're interested in Scala 3 implicits. I have many things that I think we came for the memes and the live coding, so let's keep going. So if the things are, okay, sorry, I'll show quickly this because I gave it away. But if we squint at the type classes, we can see how basically they wrapped a method, they wrap a function. So we have, what is the, the more functional encoding will be to use the A to string or A and Boolean instead of using the wrapper, which is simply a name. It's something that wraps, but doesn't compose, it's not first class. So why not A to string? Arguments too generic. It will be confused by other things. It's not discoverable because we know what show is, but we don't know what A to string is. Could be many things. So use more specific types. We can strongly type things. We can use a wrapper that instead of showing the type class, show the return type. And obviously the counter argument that allocates at each call instead of allocating once for the type class instance, we allocate at each call. So one cool thing in Scala 3 is Opaque Times, which is a kind of new type for those kind of from Haskell. And basically that removes the runtime overhead, and we have type safety, which is really cool. So we can see an example. We have show as simply a string. We have the constructor, and then just an example of a silly show instance for person, which we encode simply as a function. So how you would use it? Obviously, we cannot use context bound with this, but we just pass the instance for the function, so that's good enough. In Scala 3, I was very pleased that the discoverability of the implicit functions is very good. That means that we need a foo which has these requirements, that we need a JSON to A, we need a equality of that A, and then we need I think JSON to A is repeated, sorry. Well, an A to JSON. So it could be I don't know. I forgot what was could be an implementation for this, but forget about it. Any implementation requires these 3 type classes. And if we provide the instances as above, those will be discovered. So you can pass a person to this function. So I thought, okay, maybe if the person is on the right side, maybe it won't look at it up in the companion object, but it finds it. I thought maybe if it's A to A, instead of just A, it wouldn't, but all of them are discovered by the compiler. So yeah, a great job, the compiler team for Scala 3. That's very pleasing. There is a caveat, though, that the opaque types, the discoverability is not distinguished from the base type, so that's, I think, could be something that could be worked. But anyway, so yeah, another upside is that basically we just use the signatures and we use the types. So we could have a more interesting classes or wrappers, for example, equal, being instead of a Boolean that basically brings us all this Boolean blindness that we all swim in all the time. So we can have a proof that preserves the equality. But this is an example. Could be something else, an A to A to an optional differences, where you are returning differences. So these are interesting things that you could use. And basically, we only need to teach that difference or equal. You don't need to teach basically the type class. The same with from JSON. What's the signature from JSON, the person? We don't know. That's ad hoc. But, oh, sorry, we do know what these are. So basically, we could remove the level of interaction and just teach what's a JSON, teach what's a try, teach what's a or option or a parser. So basically, we can have many. We don't need to discuss what's the particular type class, how it's going to be implemented. We could just many. So the flexibility is increased a lot. So definitely, I will encourage to use functional encodings like this as much as possible. So types are self-descriptive. So also, there's a point that was made in a talk by John DeGois that basically is making it more accessible. If we see aggregate by key, so the minimal requirement on a V is that we need to have a combine or an add, basically, from V to V to V. And in the second case, we have a monoid. First thing is you need to teach everything about monoids, and second, even it is not appropriate to use a monoid because it's really a semi-group, but maybe you don't have a semi-group and you use monoid, so you might be over-specifying in this case, and it's clearer you don't need a zero, so V and V is enough, a semi-group is enough. So these kind of things, and as I said, I really recommend this talk by John. It's a bit long, but it's brilliant. It goes to a lot of examples and techniques to avoid type classes when it makes sense, so I do really recommend this. So, yeah, just more examples, and as we said, type classes don't compose. If we have a toJSON person and div JSON, so we could, if we want to do a div on a person and we have already an encoding to JSON, so we just could simply encode it to JSON and then do a div of JSON. That's something sensible approach, but again, types don't tell us anything. We need to have that knowledge and we need to do some, so it's not first class. Instead, functions do. So we have person to JSON, JSON div. We clearly see we can even compose that automatically. The compiler knows that those compose. Yeah. So let's go to the live coding with macros to make it more. And yeah, so I'm glad that the fire alarm works. So if this starts hitting up, we'll be safe. Yeah. So let me just change stack here. So we'll go, I don't know how is the, sorry, I'm using a different terminal. How do you change the size in Kitty? There we go. You need to have the shift. So, all right, let's have a look at this example of, we have a few functions there. We have well, it's a toy example, but it will serve. So we have a person again, and we have an implementation of show. So we are not going to go into the show derivation yet. We'll come out later, the next step, next stage of the talk. But at this point, imagine we have a show already. That we have an implementation for that, which adds years old. Well, it does the show for person. And then we have show has a from string and timestamp prefix. I don't know. We add some silly methods there. Well, the from string is not silly. It's something, an additional constructor in the companion object. And then finally, we have an MD5, which is it's a hashing algorithm for those that you haven't heard about it. And I'm basically redefining MD5 to be in the uppercase of the string just for being able to debug and visibility of what's happening. So we have, I want to run a demo in Scala 3. And so basically, I have a hash person that will do the person to MD5. And we have some, basically, some honor member of this society in the Victorian times. And basically, I want to print the person show and show what's the hash for that. So, talking about algebras, I want to think of algebras as basically a combination of functions. If we have types and functions, basically it's like a system that we could solve. We could solve to see what are the functions within those types, and we could solve it. In this case, the formula that we want to solve, it's a person going from person to MD5, which we see that if we already have something that goes to a show, to string, and then that goes to MD5, so that could be combined automatically. So that's something that we should be able to do. So now going to these experimental things that I've been playing with macros, I created a derive, which this one is not yet for any show, but it will try to derive this function automatically from the basically the system we have here of this function. So it's called derive, and the type inference is very good, so I just need to put derive. Scala 3 again, great job. And it will basically, I'm going to derive, I'm going to compile with this and see what happens. Drum roll. Let's see, there is a wriggly red there. Oh, so some error that's happening. Wait a minute, there is a derived debug that somebody left here. So let's uncomment it, see what happens. Am I having some else during the night? So yeah, let's see if this gives us any information. So, wait a minute. A really useful graph popped up that not only contains all the graphs, all the types in the system, also contains the functions between them, because basically how to find that person to MD5, it needs to be edges are functions between those types. And this is basically using the types in the companion objects. Obviously, you could go any length you want by using the methods in the instances, but I'll start just with the companion objects because that's what we do with implicit search. But I'm not using implicit search. I'm just using the methods that are defined here that, if you notice, they weren't implicit. It's simply normal vanilla functions on the companion objects. And we see this as a representation. So by the way, this is not a special effect that I pre-recorded. This is generated automatically by the macro. I'm showing this derived debug, so produces this. Obviously, it's a bit hand-wavy in the way that I had to obviously stop it at filter out the standard library and JDK, otherwise it will sprawl, obviously. So I have a small setup here, a small set of objects in this project. So basically, what this does is crawls from, if we have person and MD5, it crawls the graph of functions between them and provides the interesting things between them, so all the functions between those two types. And so let's see, we're trying to find a path. So they seem connected, but if we look again, we'll notice for the, for eagle-eyed, we'll notice that those are directed. So person has a show that goes to a show, with, yeah, that's the show instance. And also show has a from string, so to constructor, but they are directed towards show. So there's no path between person show to MD5 because I'm not using an opaque type. And so basically that show is just a wrapper of a string, but from the wrapper we cannot go to MD5. So that's why it was failing. So that's useful information. You could even create something laminar to see edges, everything. So this is just a very bare bones, but I think it's quite cool that you can put two types in your program and find all the paths between them, the network. So how can we, okay, let's save it again. Do we have the, yeah, let's save it again so we have the, yeah, let's keep it here because I want to show again. Let's try to fix this. So how can we fix this? All right, so we said that from show, we need something that goes from a show to a string. So that way, the MD5 has a hash string, so you can pass it automatically to the hash string MD5. So what we need is to string, gets show again. Yeah, just let's verbose show and return the string. So that's a reasonable thing to have. Basically, unwrap the wrapper. Just show SNS, I think. Yeah. But wait. So you see that there's nothing pre-recorded or anything. What do you want to name this method from? That goes from show to string. Any volunteers? Somebody? George, okay. I'll give you your 10 quid later, we agree. Okay, George. Okay, well, the naming is hard, we see it today. So let's add that, let's see what happens. So now we have, it's unupdated again, and now we see that, yeah, we have a show, we have a George. George showed up to save the day, because we can go from shown to string, and from a string, there is a hash string to MD5, and then, well, the one too long is just something else that we are not using. But we can find the path from person to MD5, thanks to George. So, yeah, this is, I think probably this is the most useful part of the things I work, because it gives you a network between two types, any possible finds. But so how then, okay, so, and now thanks to George, so we see that the error has gone. So the error disappeared. So now supposedly we have a hash person that does that they will have combined the functions, which is basically show and then hash the string, and it will carry on as many paths in the graph as it will do that. So let's run this, see if hash person is doing the right things. It will take a bit of time, and it probably will show some debug statements from the macro. So now it's good, yeah. And again, I'm going to comment out the things because it's going to be annoying every time we. So, can you see below? That's the print that we were looking for. It did hash it to MD5, which we saw it's an uppercase. And basically, this is the derivation of functions. And yeah, so anybody interested to see how we look? Yeah, just to show basically how we do that is there are two steps. But also I'm also very excited about the zero meta, because this was trying to do basically in the same vein. We reify the types and functions into something. I have a bigger AST with higher kinded types and vars and all that, but for this presentation, I cut it down to make it more viable. So basically, it will simply return let's find that. Let's find that AST. So where's the AST? This one. So we have a simple type, which is just a full name and fields, and function from one type reference to another type reference. So these types reference are by name, and a method, which is a function plus a method name, and then some things that Alex went through yesterday to explain some machinery for macros. But basically, the idea is that, as Damien explained the other day, so I'm quite lucky that I am after Damien, Vincent, and Alex, so you had some introduction to this concept. So basically, you refine to things that we can manage directly, and we don't have to work at that level. So, let's go back to the debug. So basically, if we go there, yeah. So the debug macro. So if you saw, just a side note, if you saw the graph had cycles, isn't it? So this had loops and cycles, and so it's done a good job on finding the path, even though there are loops. So yeah, people told me that using the Scala graph inside of the macro to find the path was overkill, but I'm quite happy because it makes it very simple and works well with cycles, and it can find paths quite easily. So yeah, simply we take the themes from the types, and then we have a method that crawls the methods, and then calls something in. This is basically the lines. Puts all the methods that are simply vanilla case classes into the Scala graph, and in this case exporting, and in the other case, basically in the solver it will basically just call shortest graph. What is it? Yeah, I guess inside this strategy. So simply calls shortest path between, well, basically it's one-liner, calls shortest path between those two tape names. And then, when this is returned, the derived macro will create an and then it will create a function which is as fused as you could write in manually. So basically, it does internally, it's not instances, or there are no summons, basically a fuse of all the functions like you would write manually. So it's very efficient and works in functions. So yeah, I wanted to show for anybody who don't know this trick, you can run any string and goes to the system, and yeah, good old Scala standard library where you can run these things. And this is calling the bash to export this graph into a dot file, dot string, export it, create the image, and call the image viewer. All that happening inside a macro that is running at compile time with very few lines of code. So yeah, I love Scala. That's a quite cool thing to do. And yeah, so unfortunately we're running a bit out of time. So let's go into the UI thing of how to this, just to see more clearly, because this code is not very polished yet. But we can look at the derivation tactic. So basically, this will be something that the user could do, for example. So you get the goal, which is a function. So basically, from type A to type B. The universe, which is all the set methods that you crawl, and the user will only have to implement this function. At the moment, I return a list of methods, the list of methods that will be composed into a linear sequence, which is not very interesting, to be honest, because this you cannot do it yourself. The interesting bit is when you start using forks in eithers and applying the logic. So this will be really a graph of methods, and that you, instead of composing with and then, you will need to do something a bit more complex to compose in, which I haven't got there yet. But it's not different. You still return a graph of this structure, which is simply strings on So what's returned from that function, from that tactic, that's what is being returned. So yeah, we saw that in the API. What we call is simply a shortcut to calling derived with tactic and using the derivation tactic. Which one is using? It's using the direct derivation, which simply does this. And the way I did this is simply calling the solver, which we saw, which is simply 2 lines, adding it to the Scala graph, find the shortest path, get the strings, return them to the macro, and the macro will give you the method. So again, Lander, you said about you will show us some derivation of type classes. So obviously that's deriving functions. I think that's the building block for deriving type classes, but I haven't gone to the function graph where you fork when you have an either or when you have a union type. So you fork different paths, and then you join when you have a function that has 2 parameters, so more arguments, so it's joining different paths. So, but most of the thing is the same principle. It's just that algorithm, instead of being graph show shortest path, it will have to compose a subsection of the graph. So yeah, we're going again in a more real example. It would be really, we want to find person string, but now we're trying to do the proper show when person has we saw that it has an age. So imagine person has name string and age, it's an int. So the same way, here I was trying to show that there's no path between person and string, so we cannot do that. If there was a function in person, from person to string, then okay, that's it, happy days. We just use this, that's the function you derive. But if the case like there's not that, we really want to derive that function, otherwise we wouldn't call in this. You will go into applying these tactics, so the same tactic that it was a direct derivation, it will be, okay, person is a labeled product. In this case, it's a string and age. Age is a wrapper for an int. So if we, basically, we peel person into this, and then we provide a function, which I forgot to put, but you will then provide your function from labeled string. If you have a function from labeled string, so basically a string to string, you can compose that into the final string by, I don't know, putting whatever you want to format that. But now comes the recursive part. So name has already a path to string, great, but age is a wrapper to age, so this doesn't have a string, so this will fail at this step. Well, not fail, it couldn't do that. So we'll need to recursively apply the tactics that we saw. So is there any direct path? There's not, but from int, so now age is a label of int, so we have person has got name and age, now age is peeled into a wrapper. You keep adding nodes to the map, to the network. And then finally, there is probably we have a trait of primitives, functions or primitive conversions, and then you know a path from the int to string. So then the whole cycle is closed, so we expand it here, but then we close basically the graph, and you will end up with a string. And yeah, this is a very simple view, but this is very powerful because you can reuse the smart constructors, for example, so you don't need to create type classes for everything. So you reuse the methods you have there, you can compose, because yeah, with type class, another problem with the derivation is you cannot change, so you need to derive this particular type class and you cannot change. If you can start doing these things recursively, then you find paths and you find things that make things easier. And yeah, this is it will be changing that direct path into something that is more graph-like. So yeah, this is how I feel sometimes explaining these things. But I think it makes sense to apply principled rules and laws to the compositions you do. Otherwise, what you are doing is a dynamically typed flow. Obviously, you have the types that tells you if that flow works or not. But basically, you are not using the types to help you derive the flow. And obviously, this example is a toy example, but the more complex your logic is, the more reason to have to add types to remove ambiguity. And this kind of derivations will help you. That will tell you, no, this system of functions and iterate is not good because there's a duplication, or you could do this, so you need to basically specify more types. And I think it's a virtuous cycle of improving So the goal should be, it's so clear, the types are so clear and everything that you can create a graph of methods that comes there. But yeah, a bit of a pipe dream, but I think we are going the right direction. So yeah, basically everything is a graph of types where the edges are functions. Well, sorry, there's something wrong with this slide, isn't it? It's stolen from Damien completely. But yeah, no, I love the set types and C graphs. Probably you heard it here first. But yeah, I think it's the same concept. I'm really excited about CO Meta. Yeah, thank you for coming. I hope you enjoyed it.